Inside our cells, the instructions on how to make our bodies is stored as DNA. This DNA is what determines your genetics and what makes you, you. We used to think that because this information was mostly fixed, it could not be changed, but we have since discovered instead that it is the viewing of these instructions that can be manipulated. Depending on the conditions, sections of DNA can be hidden from the cell, or conversely, they can be highlighted. DNA stores instructions about how to make parts of the cell, just like words in a book. When the cell needs this information, it will open the book and read these instructions. Epigenetics concerns how well the DNA can be read by the cell. This works in a similar manner to highlighting or crossing out different information. If the DNA is highlighted, it is easier for the cell to read the words, but if the information is covered over, then it is harder for the cell to read the information, even though the original information is still present. This results in different amounts of proteins being made depending on how well the cell could read the information. These changes will result in different amounts of components being made, which will change the overall balance of the cell. These epigenetic changes can be brought about by a great deal of things. Some of the more prominent causes are diet, exercise, age, and stress. Now, if these changes happen in the sperm or egg cells, the epigenetically modified version is passed down to the child, instead of what the parent has. This is important because it means that the behaviour of a person in their life can directly affect the DNA their children receive. An important example: if a person is obese, their epigenetics will be affected by this, and the children they have in the future could be more likely to be obese, as well as develop type 2 diabetes. In this study, the blood tissue was compared between individuals along a long range of BMIs. BMI stands for Body Mass Index, and is a measure of obesity which takes into account the height and weight of a person. And a correlation was found where the more obese a person was, when they were both 1, more likely to have received epigenetically modified DNA from their parents, as well as 2, be creating more epigenetic modifications to their own DNA sequence. This was measured by creating markers which would show if there were modifications at different genes and comparing how many each person had with their BMI. The correlation here shows that the epigenetics both causes obesity, as in the first graph, but also obesity will increase the rate of modification in the second half, which means the system is not one way. Therefore, if a person is obese, then their cells will modify how they read genetic information. When this information is passed on to the children, these children will receive the modified version of the genes. This can lead, as was said before, to the children being more likely to become obese as well, and or to develop type 2 diabetes. Type 2 diabetes is a condition affecting 3.42 million people in the UK, a number that is only growing with time, and it is typically brought on by a high-fat diet. It is critical that the diabetes crisis is solved, as it costs the NHS over £6 billion per year, a large portion of its budget, and this expense is only growing, and predicted to grow further. However, we have found that different people have less tolerances of these high-fat diets than others. These people with lower tolerances are more likely to develop type 2 diabetes eating the same diet. One of the factors that can cause this, as we have seen, is the lifestyle of a person's parents, such as their diet, exercise levels, stress, and age. Therefore, it is important to maintain a healthy lifestyle, not only for your own sake, but also for your future offspring, as issues caused by obesity are not limited to the individual. On the brighter side of things, this research has some very promising development, as it can lead to lots of clinical applications where epigenetics are used to reverse these problems through the use of drug therapies. We can also create a test to find out whether or not a person is at high risk of type 2 diabetes through their epigenetics and provide lifestyle advice accordingly. One would only need to take a blood swab. This highlights the obesity issue that is going on in much of the Western world at the moment. There are many places to go for support in combating obesity, and if you are ever in doubt, then consult a GP. After all, you could be saving your kid's life.